Hi, I'm Dave Robinson, and welcome to another one of my screencasts where I'll be using R to analyze data I've never seen before. As usual, the data comes from the Tidy Tuesday project, which is a fantastic weekly data project in R from the R for Data Science online learning community. Let's see what data I have this week. We have Bob Ross paintings. Bob Ross is wonderful. There's these paintings, a show I think called The Joy of Painting from on PBS, where he would paint an entire painting in the course of a video and describe what he's doing. Which actually, now that I think of it, is a little bit similar to some of my screencasts. We can grab the data from here. I'm gonna skip the hints, but look at the data dictionary. Alright, so as usual, I'm going to work in an RMD file. I like to do library tidyverse. I also like to do theme set, theme light. My favorite ggplot2 theme. Alright, we've got loads of columns in this one. Interesting that it only mentions 2 columns here. We have episode, title, and then loads of information. I'm guessing I'm going to want to gather this. Okay, I think each of these is a feature, like whether they're... Wait, hold on. Binary presence of the element in the painting. Okay, that's pretty cool. So we have a wide data set now of like episode, title. I'm going to use a package janitor to say janitor clean names. Get them into snake case, which I like a little bit more. And what I'm going to do is gather every, this is a really wide form. I want everything besides the episode and the title to be in element, present, and then everything besides episode and title. So now I've just turned it a 4-column data frame where we say episode, title, what the element was, whether it was present. I likely want to just filter for present is 1. That way I get the 3,000 elements that end up being present in this data. So that's in these episodes. So that's I think, yeah, that's probably the way I would. That's probably most of what I'm going to work on. So now we have elements present. So I can just thinking about this, I probably want these to be in like sentence case or so. Maybe even title case. Yeah, I'm actually going to do a little bit more cleaning. And I'm going to say element is string to title, string replace. Element, I replace the underscores with spaces. And I also turn it into, here we go. I like that a little bit more. Is Apple frame? All right, so, and I can drop the present column. I don't need it anymore. Okay, so now I can see episode, title. The title, I just don't love the all caps, so I'm going to go ahead and say title is string to title. It just hurts my eyes a little bit. I say title and element. How long have I spent on this? About 5 minutes. All right, we also notice that it's a bit of data cleaning we want. We probably want to trim those quotes out from each of the sides of it. So there are a few ways I could do that. I think the simplest way is string remove all double quotes from the title. So did a little string cleaning. Here we go. I kind of like that. So now we can ask a few simple questions. I've got some ideas already. I'm probably going to do some clustering, find what elements tend to appear together. But before we get to that, I might also say, I've got seasons and episodes. It just hit me. I want to make sure no 2 episodes have the same title. So we're going to say is count title. Back when it's still a tidy 1 row per each of these. Okay, we do have Lakeside Cabin, Mountain Waterfall popping up twice. Worth noting. But mostly what I want to do is I want to grab out... I'm thinking about this. Do I want to grab out the season number and the episode number? Yeah, why not? But I'm going to keep the episode code in there as well. So what I'm going to do is use extract. I don't know if you've seen this before, but I love this function. I've used it in a few Tidy Tuesday screencasts. From episode, I say I want to extract the season, and the episode number from based on the regular expression S, some number of numbers or letters or whatever, E. So these are called capturing groups. And now I can say, I'm gonna for a moment drop this. Notice I have 17 and 8. I want those to be numbers. Convert equals true will automatically detect now those are numbers and translate them as such. And I also don't actually want to remove equals false. I don't want to remove the episode. I just like this season and episode popping up. And I can now arrange it in ascending order of season and episode number. That's pretty handy. Alright, so now I have, I'm going to actually call it Bob Ross Gathered. So this is our data set. We've cleaned it. I really like some of the steps I've gone through. Not everything's perfect. Mount McKinley, this case should be capitalized. But we have these elements. We have these titles. We have and we have them in a good order. All right, that was really fun. But let's get to some questions we can answer. Let's start with exploratory questions. Exploring the paintings. So the first is I want to know what are the most common elements. That's it. I almost always start with a sort, and you might know that I would often account with a sort equals true. I often also say let's take the first, could be 16 or 20. Let's do an element, an n, a geom call. I do this in almost every screencast. Just a really handy sequence of steps to say I'm going to reorder by the most common ones. Here we go. And now I know that trees, he likes painting trees. I think he is a classic thing where we say there's a classic cliche of Bob Ross to say this is a happy little tree. So these are the more specific types of trees: deciduous, conifer, clouds, mountain, lake. All of these so far so most of these so far are natural, except for structure. If we went farther down, we'd probably get to things like house, cabin, other less natural elements. But this is pretty fun. So we can say tree or trees up at the top. I could clean this up, but really we get the idea. I'm going to do top 25 so I can get even more of a bit of a feel for this. I see there are 66 elements total. And yeah, the most common structure, it looks like not man-made type, is a cabin, and or sometimes a path. And all right, framed, I'm guessing means was the painting framed, and that's really so. Bob Ross does a lot of painting of landscapes, of forests, of things like that. So that's pretty cool. I could also say, what are the most crowded paintings with the most, how would I call it, the most elements in them. So there I could count, but I really want to look at the most crowded ones, so I'm actually going to start with an add count on title, which means I've now said, this one has 6, this one has 9. I wonder, if I arrange descending by n, the count of added, it's called Lakeside Cabin, and this has bushes, cabin, circle frame, clouds, deciduous, framed, grass, lake, structure, tree, etc. That's one. Wow, a lot of things in this. A lot of items in this. Wait. That's because it's doubled up. Silly me. I want to add count on the episode, not the title. Here we go. Now we see that, in fact, Mountain Oval, which was in an oval frame, and indeed has a snowy mountain. Oh, Steve Ross, maybe that's, I don't know, maybe Bob Ross's brother or son. And yeah, we see trees. It was framed in an oval frame. Okay, that's something that's stuff we learned about Mountain Oval. Who wants to see Mountain Oval? I want to see Mountain Oval. What's it look like? Okay, so Steve, I'm gonna mute that. So this is an example. I really wanted to show an example of Bob Ross before before the episode was over. Oh, it looks like this one. Oh, it was guest painter Steve Ross, which I'm gonna guess is his son. Maybe he says it in the intro.
So I'm going to turn it over to Steve, and I'll be back at the end of the show. Steve?
I should do a guest. I could use a break sometimes. I should do a guest data analysis screencast. So that means that Steve Ross is not an element in the painting. It's someone who paints the painting. It's an oval, and I'm guessing when we get to the end, we're going to see that it's framed. No, we don't see a frame. But in any case, that's the most crowded painting that anyone's done. All right, so that's fun. I wonder how common is Steve Ross? Is that a common? Has he done 5, 6, 7 paintings? I really like to zoom in on my data like this. Like every once in a while, it's really handy to do that. Yeah, Steve did 11 paintings across the many seasons of the show. Okay, so that's cool to know. All right, and yeah, so we learned some things about the most crowded paintings. I could ask questions like, what does Steve paint as opposed to other people, as opposed to Bob Ross? We might not have enough data to quite tell that. Okay, how have Ross's paintings been changing over time? Here's a worthwhile question. What I'm going to do is, I don't technically have to aggregate it by season, but I think it's probably the way to do this. How many seasons are there? Ooh, I made a mistake of doing this at the element level. So I'm going to instead say episodes is n distinct episode. 13 episodes a season for 31 seasons. Isn't that remarkable? Almost always 13. Maybe there was no elements in the other one, but wow, that's so cool. I don't think I can make. How many episodes is that? I can see it in the raw one. That's 403 episodes. I think I've done about 25, or maybe 20 episodes of this 20 to 25 episodes of this screencast. I'd love to. Let's see if I can go to 403. Bob Ross. I'm no Bob Ross, but yeah. So we have these season, 13 episodes a season. How have they been changing over time? Well, let's look by season. In particular, let's count by season and element. And just to confirm, we never have the same episode element appear multiple times in the same episode. Good. No, we don't. I want to make sure of that. That would have been a data quality issue. It couldn't have happened because of the way that we gathered it. So now I feel better about that. All right, count season element. That's handy. I could sort and say, well, every one of them. Ooh, almost every single episode in these seasons has a tree. Has a tree or has trees. Okay, so like, yeah, lots of things that occur across most most seasons have trees. Really good to know. I'm gonna, before I do that, do a quick add. Nope, I'm gonna do a group by. I was gonna normalize by season, but I just realized that's silly. They all have 13. No, they all have 13, but they don't all have 13 elements in them. I could say add count of season. Or, nope, I don't. All right, I'm going to start by mutate number number elements. Total elements is, the total number of elements in the season is n distinct episode. And that way I can then count. I just realized, does add count have a name argument? If it does, it was added recently. Ah, great on us. What we do is we say add count of episode, name equals total elements. That's the total elements in a season. And I throw the total elements into this count. Here we go. Season 30 had 8 elements in total. On a group. Nope, I don't need the group anymore. I was trying to make this concise. Add a count, then count. Notice here I was trying to add the total number of elements in the season, not in the not of this one episode of this one element. So, for example, season 30. Oh, season. Look at that. Season 2 had 114 elements. 13 of them were trees. Honestly, tree and trees, they're basically the stop words of Bob Ross paintings. If you're familiar with stop words, a stop word is a wait, where was I? Yeah, a stop word is like is something that's so common that that you just remove it, like the and. All right, so I'm gonna say percent used, and we do n out of the total elements. Do I want that, or do I want the percentage of the? I just don't. I'm gonna filter out tree and trees. Not element in tree, trees. And then I can ask a question. I could say, for when the element is deciduous, it's deciduous tree, does it change over the seasons? I doubt it. If I had to guess, I doubt it's been getting more or less common. And yet it looks like it hasn't really, especially if I do this. Yeah, I don't think that's a trend. I could try another one. I could say, does Bob Ross become more or less likely to draw mountains? One issue I have with this is I'm not actually a fan anymore of percentage of elements. I'm a fan of percentage of seasons. So I think they're all 13. They're not quite all 13. Some of them have 12. I'm going to change my mind about my idea. I was normalizing with the number of elements, like, oh, if this makes up only 10% of the elements in a season, then that's one thing. I don't like that anymore. Yeah, it's just not like, it doesn't feel to me like, oh, just because maybe the paintings have gotten more crowded, maybe there've been more features added. I want to think instead in terms of group by the season, add number episodes is n distinct episode, usually 13, but I want to make absolutely confident percenting. I call it percent included. So this is season by season element. That's an aggregation, and what I'm showing is that, yeah, if I take in season 3, 10 of the 13 episodes involve deciduous trees. How often does Bob Ross paint mountains? We'll say percent included. It'll really always be between, yeah. So like mountains were included in, I'm going to turn this into a percent scale. Mountains were included in 70%, almost 70% of season 1 and a lot of season 9, but they never really dropped below 40%. Mountains look like they're pretty classic, pretty standard. All right, so that's one thing we can learn. I may want to apply this to many elements. How do I want to go about doing this? I could do group by element total equals sum of n. Yeah, it's only one per episode. And now I can say 227 episodes involve deciduous trees. 179 included clouds. Those are ones that are probably worth graphing. And now, but why did I do that? Oh, I'm throwing an ungroup. Notice it's all me keeping track of. I'm counting these individual facts. Season 3 has 13 episodes, 10 of which include deciduous. Deciduous across everything is 227. All this code is meant to keep track of that so that I can say element total is, I don't know, greater than 100. And we throw in, I'm going to try out color equals element. There, that's, well, there are no bad graphs, only happy little accidents, as Bob Ross would say. So I'm going to facet this. I'm not crazy about that. Look at all the things overlapping. I'm going to facet it, wrap it by element. Could probably drop the color. Does anything get more or less likely over time? I don't think so. Maybe Lake a little bit after the first few seasons. I'm not seeing that. Just want to check I have plenty of time because I really do want to do clustering. All right, the big ones, I don't see it. I'm actually going to do 50. So I'm going to include as many as have at least 50 across all the seasons. Cumulus clouds look like they might get rarer, but there's really, it's really hard to tell. Okay, I'm going to share here a decision point. I could have fit logistic regression models to see changes over time on each of these. That's one good approach to. If you want to try it yourself, I really recommend it. You want to do like multiple models with Broom. Have used multiple models with Broom. Broom. There's a great bit in R4DS, multiple models with my Broom package. Many models is the word I was looking for. And so this is, I don't maintain Broom anymore. Alex Hayes does, but I need to task at it. But the story here is we could have nested the models, looked at the slope. I think we're going to have so little signal here, it's not going to beat our multiple container hypothesis testing. So I'm going to say, I'm just going to note we could have done many models with Broom, because I want to get on to clustering. I want to talk about what tends to appear together. And maybe I'll start saying, I might also do some predictive modeling, say, can I predict whether a river is included based on the other elements? That I likely will do that. That sounds pretty fun. But I'm going to start with clustering. Start with by season element. Not season element. I'm going to start with Bob Ross gathered. All right. And I'm going to say what tends to appear together. For this, we're going to use another one of my packages called YDR. So YDR is meant as a pairing to the TidyR package. It's really good when you want to, it's a widen, process, then retidy a data set. So the, where's an example? I think I have a graph somewhere. That's right. I won't show it. You can look a little into the theory behind YDR, but the main thing I want to show is that we can say pairwise correlations between elements based on whether they appear in the same episode. So just like that, we can say, do deciduous trees tend to appear with bushes? Well, they have a slightly positive correlation, but trees and bushes have a more positive correlation. You almost always want to add sort equals true when you're doing pairwise correlation. All right, can we find problems? Whenever there's a person, they're on fire. Huh. Can anyone spot the problem with my analysis? The problem, so first of all, that's, I think, amazing and sort of a discovery about Bob Ross we never would have guessed. But here's what I suspect. Take your original data. I bet you only one graph has a person, and it also has a fire. What is that episode? It has a campfire. Okay, that actually makes a lot of sense. Wow, that's pretty cool. Oh man, I gotta watch some of these. Yeah, this is pretty cool. All right, so what that tells us is we probably want to remove any with an episode with an element total that is too low. So what I could do is I could say, kind of as we've done with some of the earlier work we did, we could say add count element filter n is greater than 5. And we work with pairwise elements between these. Oceans and waves almost always appear together. Winter and snow, ocean, beach, framed often appears with oval frame. That makes some sense. Like some of these, remember, aren't like two objects that appear together. They're like a feature that appears with other items. So these are our correlations. I'm not going into what a correlation is here. I'm assuming people are familiar with it, but it's a number between -1 and 1. 1 would mean whenever one appears, the other appears, especially in a case like this, which is called a binary correlation, which has another name. I think the phi coefficient is the other name for this. This would mean that they almost always appear together. The lowest ones would be the ones that never appear together. If I said arrange by correlation, oceans and trees don't appear together. All right. Why is this interesting? I'm actually going to up the threshold a little. I don't want any of the really rare ones. Yeah, everything here appears in at least 10 paintings. Okay? Why is this interesting? Because I could ask, item 1, what do waves appear with? And I'd say, oh, waves appear with ocean, beach, rocks, cloud, cumulus, sun, and so on, and then very rarely with the rest of the nature area. Ooh, I know where I'm going with this. Yeah, so that's one thing we found. And then the other side, we could have said, bush. What was the really common one? The bushes. Yeah. What were some of those other pretty common ones? I'm gonna graph this again for inspiration. We could have said, what tends to appear with a river? I kind of like this one. We could say, plot item 2 by correlation, geom call, coward flip, mutate item 2 is FCT reorder, item 2 by correlation. Item 2, notice, is whatever isn't river. We can say what tends to appear with a river? And the answer is waterfalls, trees, and grass and rocks. You never see a river and a lake together. Not never, but highly unlikely to see a river not necessarily never. You don't see rivers with lakes. You don't see them with oceans, waves. Steve Ross, slightly less likely to paint them. That's the idea. And I could also note here, among elements that, among elements that appeared in at least 10 paintings. This is pretty cool because we have 34 items. All right. So that was pretty fun. What are we going to do? What are we doing next? I noticed something. We have waterfall, trees. I liked this. I liked that we did. I thought it was fun to look at one. I could have looked at something else. We could have said what tends to appear. I could have said Steve Ross. So guest is linked to Steve Ross because he's a common guest. But other than that, a little more likely lakes, a little less likely structure. I don't know. Let's look at structure. And we're going to see cabin, barn, etc. That's a little, I think, still not quite as exciting. What if I said snow? Snow appears with winter, often with cabins, with conifers, not with grass, less with rocks, ocean, etc. Snow, winter, highly linked. We already knew that. All right, so what are we doing here? I'm trying to find interesting trends, but I'm doing it in a non-systematic way. I'm doing it I'll jump into I'll pick one item and see what correlates with it. What I really want to know is what are clusters of things that belong together. I'm going to show that in two ways, one of them qualitative and one of them quantitative. The qualitative way is a network plot. What I'm going to look at is correlation among these correlations. Let's take only the top 100 strongest correlations. I'm going to make a network plot out of them with the wonderful gggraph package. gggraph and, oh no, I can never remember this. I think I can do graph from data frame. That's the thing I can do. I took these top 100, I made them into a graph, and I gggraphed them with geom node point. So gggraph is a version. I've done it in a couple screencasts. It's a version of the. I'm not done with this plot yet. It's a version of the grammar of graphics adapted for what do you call it? Network plots. So what this is showing is I want to look at clusters within this data among the 100 strongest correlations. I say AS alpha equals weight. Alpha equals edge link. Correlation. Right. I'm not seeing the alpha. That's a little annoying. But the last part that I really need is geom text label equals name. geom node text. I'm a little rusty with the plot with ggraph. And I say vjust1, hjust1. We see a couple of big clusters. I also usually throw in a set seed so that I'm also going to throw in a few more connections. How's this look? Too many connections. Usually I just feel this. I just kind of feel this out. Even that I don't like. 100 was probably right. All right. What I'm saying is, what are typical clusters? Well, guests are a little more likely to do flowers, sure, but really what we have here are we have a beach cluster, everything from sun, waves, ocean, rocks, beach, clouds, and we have a nature cluster. And that stretches from structures, your path, barn, fence, and cabin, and path and barn. But yeah, here's your structure cluster. Often appears with winter, snow, conifer trees, and here's your mountain cluster. Snowy mountain, mountains, and then our nature kind of forest cluster. Trees, bushes, deciduous, river, waterfall, and so on. So that's a fun, quick analysis. What would happen if I put back in the ones that occurred 5 times? How's this graph look? Really similar. Did I miss a step? Maybe. Maybe not. Maybe it didn't add much. It looks almost basically identical. We have palm trees added. I think palm trees is new and cliff is new. Okay, we could spend more time on this. The one thing I am going to point out is with these you often want theme void to make it a bit of a better network plot. There's a lot more you can do with networks. But one thing it shows us is there's some major dimensions here. The biggest by far, I'm pretty sure, is going to be oceans, everything beach related, and everything nature related. Maybe everything structure related as well. There's going to be 3 types of dimensions. What do I mean by dimensions? Well, we're going to be doing principal component analysis. I think that'll be the final step. We have am I going to do machine learning? Probably not. I'm going to do principal component analysis on what gets included in a painting. Principal component analysis asks what trends predict the most about one of these paintings. I'm going to try and explain it really quickly. I'm not always good at explaining these, especially since I haven't prepared. But here's how I would try and ask. I would think about it. If I could get one yes or no question of what type of painting is this, and that would tell me as much about the elements in it, what question would I ask? An example is, if I'm looking at this, I suspect if I wanted to learn as much with one yes or no question, with one to answer question, I would say, is it more of a beach painting or more of a nature painting? And if they said it's a beach painting, I would say, oh, I think it has all these things. If they said it's a nature painting, oh, I bet it has, I'm pretty sure it has trees, probably has river, etc. If I ask a second question, I might say, does it have a structure in it? And as soon as as you said it has structure, I say, it might have a fence, a barn, a path. That would be like me guessing what kinds of yes or no questions I would say that tell me as much information. Now, understand, I could have asked 60 whatever questions. Yes or no, does it have a beach? Yes or no, does it have a person? Yes or no, does it have fog? I could have asked that, but this is a way to because we have what we call structure to this space. We have a 66-dimensional space. We're going to reduce down into fewer dimensions. We're going to say what are the big dimensions that really matter, that drive a lot of the variation. What dimensions drive a lot of the variation among paintings? Now understand, my explanation is hand wavy, but PCA mathematically is not hand wavy. PCA has very specific meanings that you can work out in equations. And maybe we'll touch on some of them, maybe we won't. I just want to note that that don't think that just because my descriptions are hand wavy that it's a hand wavy concept. All right. So I'm going to look at Bob Ross gathered. Am I going to do this? I'm thinking about whether I use my... No, I'm going to show how to do PCA. Do I show the long way? Yeah, I'm going to show the long way. What I'm going to do is do, no one ever uses the reshape2 package anymore, but I use it sometimes for cases exactly like this. I need to say acast, I need to turn this into a matrix with title and element. Do I have a value var? No, I just have, it'll be binary by default because of the length. It'll take the length to aggregate it. It's a little weird. I just created a binary matrix. Notice it's very similar to the original form. I did a little cleaning up, so I don't mind doing the binary matrix. We have 398 rows and how many? 66 columns. Later I might remove the uncommon ones. I'm not 100% sure about that yet. Okay. So, I have this matrix, and what I'm going to do is apply singular value decomposition to it. And I'm also going to mention that I always forget. Do I need to center the? Yeah, I need to center something. I always forget when I'm centering. Yes. Okay, yeah. I need to center the columns. Some people say center the rows. I can never quite remember. The problem here is that if I look at my columns, oh, nope. The columns are the, oops, I got this backwards. I meant one row for each of the call sums. I meant, yeah. Here, oh. What's happening? Just check. Title is going to be on the y-axis, meaning one row. All right, so explained by element. Yeah, this is right now. The problem is that the first principal component, the first source of variation, will just be based on the fact that, oh yeah, they always have trees. And like that's the only thing the first principal component will care about. I'm removing that from it. There's a trick to this, which is, I'm going to remind myself a moment, it's the transposed binary matrix minus the column sums of binary matrix. I'm sorry I don't have time to explain it as I go. Oops. Look at me go. Column means. That's what I was looking for. Here we go. Now all the column means are, column sums are about 0. What I did is I took every column and I subtracted the middle of it. Ends up, since a binary matrix ends up a lot of repetitive code, but now the columns are balanced. The more they have ones they have, the more they're above 0. So yeah, that was one start. I always forget exactly what I'm doing here, but yeah, centered matrix. I'm pretty sure that puts me in a better position here. Okay, sorry that I'm being a little bit vague. I also am trying to respect the timeline. So what I do is say singular value decomposition on this matrix. That's done with a built-in function svd. I'm going to call it svd result. What this gets is a list of 3 items. A D, a U, and a V. And it's a little bit vague. So I'm gonna work with it based on tidied versions. So first, let's tidy the U matrix. Actually, let's tidy the V matrix. That's my favorite one. What we do is the V matrix. Again, this is not like a mathematical intro. I have done this before in sessions. Tidy comes from the Broom package. What this says is, in this column, with this PCA, what is the loading? How much does this column contribute to the PCA? What do I mean by column? Well, a column is comes from the column names. Every column is one column from the original binary matrix. You take the binary matrix, we index it by column. Now I'd say, this is apple frame. This is Aurora Borealis. This is bridge. We see that beach was negative on this one. It's already a good suggestion, and bush is positive. I bet you that, just like I thought, that first principal component, it's going to be about how much nature. Is it about nature? Over here, as opposed to being about the ocean, waves, beach. That's one of the biggest sources of variation. How can I determine that? I'm going to call this SVD I'm going to call this element weights. I'm not always great at my terminology, but the story here is there are 66 principal components. I'm going to care only about the first one. Look at the first one, and I want to ask, what order do these fall in? Well, the top is mountain conifer, snowy mountain. How mountainous is it? And at the bottom, bingo, ocean's wave. Also deciduous got in there. Sun, rocks, palm trees, also some structures. So let's actually graph that for a moment. Let's say, filter top n 20 by absolute value of value. This is our first principal component, element by value. Coord flip and mutate element equals FCT reorder element by value, by the PC, by the principal component strength. So here we can say first principal component is mountains versus oceans. That's pretty handy. So like mountains, especially like snowy mountains, and yeah, the other end is the ocean. Similar to the first suspicion. The second principal component is what separates the beach and the clouds, like beach, waves, ocean, clouds, from trees. Okay, so basically the first one was mountains versus, you can kind of describe them based on their most extreme values. Oh, I see how this worked. Notice that deciduous ended up negative in this direction, less correlated with mountain. The first was like mountains versus deciduous and ocean. And the second principal component is what separates, that's like the next question you would ask, what separates trees from the ocean? We don't need to separate mountains out anymore, not as much. But we have to but the second one is all about, do our trees separate from our clouds? So that's a that's the way that we can describe. Yeah, I wish I had a data set of these paintings that I could pop them up into a graph and stuff. I'm just thinking for a moment about how I'm going to go about this. Let's see. These are the first two principal components. I'm going to look at the first four principal components all at once. I'm going to group by PC, and now I have the 80 values that are. We probably only want. We probably only want 10, or we're going to get into trouble with our graph, the size of the graph. And I actually now need reorder within. Where does reorder within come from? My understanding, I don't know if I have the latest version of tidy text. I'm not going to do that. Ooh, nuts. Ooh, boy, gotta work on that. All right, reorder. I think that's just because I reinstalled it. Reorder within, fantastic. From the Julius Silge recently added it to the tidy text package, and we say reorder within element by value within the principal component, and now I say scale y reorder. Nope, x reordered. Oh, I need an ungroup after the top end, and a facet by, so this is all about, I wanted to facet wrap by the principal component. So, oh, and scales equals free. I've done this a couple times, which is why I'm rushing through it. Wrong argument. And I could have done more than that. So here I'm looking at my first four principal components. That's a pretty good graph. I can say title, first four principal components of Bob Ross paintings. So it's like mountains versus oceans. Mountain versus ocean. Then deciduous and trees versus ocean is the second biggest source. And then we say, this is all about snow and winter versus river. The order is irrelevant. It's completely arbitrary. You could say it's snow versus the river grass versus like spring. Snow so like winter versus summer. In the summer you see river, grass, bushes. In the winter you see snow, winter, cabin. And finally, lake versus river. We actually saw those two as negatively correlated. When two things are strongly correlated, it's a good chance some principal component will be about separating those two. So these are the first four principal components, and these are pretty clean results. So that's one way of exploring these of elements. So I actually mentioned these are the elements in the painting. So I'm just going to quickly note down 1, mountains versus ocean, beach, and deciduous trees. So we have mountains and conifer versus that. And then there's another type of tree. 2 is deciduous trees, especially deciduous, versus ocean. And clouds and stuff. 3 is summer versus winter. I'm going to say spring, summer versus winter. And 4 is lake versus river, which we know generally don't appear together. We see some other things. Lakes can appear with some kinds of trees. River can appear in the winter. But that's mostly because principal component 3 was so strong. I think this is mostly lake versus river. All right. And I think that was one of the biggest negative correlations, if not the biggest. All right. That's one way we can explore the results of principal component analysis. A second way is that we can look at the painting weights instead of the element weights. How do I do that? Well, I tidied the V matrix first. Shoot. I'm going to restart R quickly. The problem, what just happened is tidy text took over my tidy augment glance. I bet this fixes it. I'm going to quickly rerun a few things. This. Rerun YDR, get this. Oops. This. We did a lot today. Look at that. Oh, and I did not know this would mask those objects. Okay, I need to look into that. I don't know the reason. That hasn't happened to me yet. But I bet if I do, yeah, broom tidy, it'll work. All right, good to know. Didn't used to. It should have re-exported those objects. Gonna have to look into that. All right, so if I do broom tidy SVD result, I was doing the V matrix. The meaning behind UDV is a little obscure. It has to do with the names of the matrices, the mathematical definition, but I just happen to know it. But if we switch to U, we're no longer working on columns. We're working on rows. Watch this. We can actually say painting equals the row names. Notice I did column names up there. The row names of the binary matrix by row. So just like every element has a strength in these principal components, every painting does as well. And that means I can ask the question, what is the painting that is the strongest in principal component 1? So I can call this painting weights. And now I can say, what is the greatest source of variation in Bob Ross's paintings are between mountains and oceans, especially snowy mountains and oceans. So I bet if I say filter for PC equals 1, arrange descending PC, descending value, I bet you the top will have a name something like mountain in winter. Mountain waterfall, in fact. But also Frozen Solitude. Frozen Solitude seats all winter things. And we do have a summer in the mountain making in the list because it's God Mountain, probably conifer, and so on. But definitely not nature. So like Mountain Waterfall nailed it. Can I tell why? Well, let's find out. If I went to Bob Ross Gathered and I filter for the painting is Mountain Waterfall. Title is Mountain Waterfall. Look at this. It has mountain but and mountains are both there. It must have. It has conifer. It has snowy mountain. It has lake. Nope. Yep. It has lake. It has everything that is up here. Tree and trees. Does it have bush? It has bushes. Winter. It's got to be winter if it's called. Oh no, it's not. It's actually not winter. That's the one. Oh, no, it has snowy mountain. Huh. Funny that it doesn't have winter. All right. It has all these things. Doesn't have snow, but like it has most of these. None of the negatives, as far as I can tell, except deciduous. So, but the point is, this is like a perfect match. But then if I said frozen solitude, we see that's the opposite. That's also similar. It's got conifer, it's got mountain, it's got snowy mountain. Okay, good. But what if I looked in the other direction? There it is. It's all the beach ones. Balmy Beach, Island Paradox, Crimson Time. Every one of them is somewhat beach-y. So that's pretty cool. By the Sea. So this is your spectrum of Bob Ross paintings. So what are the two most? You could almost say these are opposite paintings, at least in our reduced dimensionality space. One is called Frozen. Nope. Frozen Solitude is not the extreme. One is called Mountain Waterfall, Bob Ross, and it looks like this is Mountain Waterfall. I would have loved to have the data. We could have done some plots of the spectrum. So we see mountains and a lake. That's one end of the spectrum, and the other end of the spectrum was called Balmy Beach. Yeah, those are definitely very different paintings, no question. Very different paintings. Okay, that's one dimension. But I'm actually gonna show, instead of looking at the second one, we probably would see this is another couple of really beach ones. These are some very deciduous tree ones. Probably don't have mountains in them. What I'm actually gonna do is plot them. Graph them in the same way I did the earlier analysis. In fact, I can get really close. What I'm going to do is say painting weights, pipe through all of this. The only changes I make is I change painting in these three places, and I can just say Bob Ross paintings. I think this might line up exactly. I'm not 100%. Let's find out if it works. Here we go. What this tells us is yeah. So we have Mountain Waterfall. I'm going to show a few more just in case they're positive or something they're hiding here. What this shows is, in this dimension, we have let's look at the two graphs we have. Here's one. I'm gonna color this up a little bit because this is probably the one I'm going to end with. And I like to add some color. Fill is PC, don't show a legend. Here we go. So remember, it went mountain to ocean, trees to ocean, summer to spring, spring to winter, lake versus river. What are the extreme paintings of each of these? Mountain Waterfall, Balmy Beach. The most extreme in dimension 2, we don't even see the positive extreme because it looks like we really have some big negative extremes. It's basically just, this one is all about the beach. This one is like all about Surf's Up is the most extreme one. Let's look at that. Surf's Up, this is the most extreme of the ocean. Makes sense. This one is all our winter dimension. It's kind of stronger in this direction. I think that's because there are fewer beach and fewer winter than there are the rest. The extremes on this side end up dominating the top, the largest values. That doesn't mean that the average of these is still going to be 0. So if we looked at all the paintings, if I actually just quickly, if I said, here's PC is 2, I'm going to quickly sort this. We're going to see that, notice there's all these strong values, but most of them are going to be close to 0 or like mildly positive. Yeah, so that's one thing we find. But the extreme values, you're on 2 and 3, here's the beach. What are the most beach ones? All these. What are the most wintry ones? Lonely Retreat is the most wintry one. Bob Ross. This is the most wintry one. It has everything. It has snow. It has a cabin and a structure that goes with that. If I flip back, it's like it has winter, snow, structure, cabin. I think conifers. Is there a fence in there? Maybe, I can't tell. But it's got all the stuff that would really even that doesn't matter. It like matches all of these, and that's what makes it a wintry painting. And then you see the other one was lake versus river. Boom, lakeside cabin. Don't have to guess about that. On a clear day, but I'll just say lakeside cabin. This is a very lake. Wait, one of these is lake. Yep. This is a very lake one. And then we can say one is lakeside cabin, and the other is on a clear day. I hope you don't mind that I'm going back to Google. I really just like to look at the paintings themselves. I don't like to theorize. I like to on a clear day. Where's that river? There's the river. Wait. Is that a river, not a lake? Oh yeah, it's a river, not a lake. That's really cool. Actually, can I look at a video of on a clear day? And this it's muted, but you really see yeah, there's your classic river painting. It looks like that's not a lake painting, at least according to this. But yeah, all right. So that's some of those dimensions. Wanted to have fun. I could look at the top 6, and I always do want to have fun. And they're not. Sometimes they start breaking down their interpretability. Hideaway Cove on one side, lakeside cabin. I don't know. I'm Waterfall versus. Well, what if I looked at the elements and I looked at the top 6? Clouds versus lake, bushes versus grass. Both reasonable, but I'm gonna skip that. I'm gonna stick to this, the dimensions of the Bob Ross paintings. Yeah, so I really like principal component analysis. I really like how I was able to break down these core dimensions that explain the variance. Last thing to mention is we didn't actually do it yet, but you can tidy one more thing, which is I can say SVD result. Matrix is D, the third one, and this will actually let me share PC and the percentage of variation that each principal component is responsible for. What this actually shows us, the top 5 are responsible for a lot of variation, like an extra amount. And then it starts dying, and this is percent of total variation in the matrix that's responsible for it. Then it starts dying off, and right around here, the 16th principal component, you're from then on, there's it kind of levels off, and after the first half of the principal components, there's nothing. What this shows, there's a lot of structure in the data. If the data were perfectly random, the elements appearing at haphazardly, it would be very flat. It would be each one explains the same amount of variation. What principal components try and do is say, this is the most important, explains 16%, second most important, 12%, third most important, 10%, fourth most important, and then we work our way down from there. And you usually want to do a cutoff somewhere where there's a solid gap. So 5 principal components would be a solid place. 4 is not so bad either. Okay. All right, so that was our exploration of Bob Ross. First doing some exploratory analysis, doing some clustering, doing a network. Where's my note? Yeah, that's some correlations. Doing a network, and then ending with some principal component analyses. That was fantastic. I hope you had a really good time. I know I definitely did. And I'll see you next week.